Well, hello everyone. Welcome to another episode of CNC Basecamp. Got a great show for you today. What I'm really excited about is our new CNC router. This is the X-Carve Pro from Inventables, and we're really thrilled to have it. What makes this machine so great is the format size, 4 by 4 feet. So it really handles large projects easily and has a lot of capability. Another great thing about it is the software system, Easel. Easel is very intuitive, very easy to use, but for an old die-hard Vectric user like myself, I can import Vectric VCarve Pro right into it. So it's very simple to add a machine like this with no struggle. So today what I'd like to do is for us to make a mid-century credenza, a furniture project. This episode is sponsored by Inventables. Design it, build it, sell it. Learn more at inventables.com. So take a look at the computer screen and I'll show you. I'll move it around a little bit here for you. So in the mid-century tradition, it basically consists of a carcass and it's suspended between 4 solid walnut legs. We have sliding doors and some attractive walnut poles that we're going to make. So the project basically consists of the inner carcass, which has 2 ends, a top, a bottom, and a back. There is also on the inside of it a vertical divider and room for 2 shelves, one on either side. We're going to start out by making that plywood carcass. Once we're done with that, we'll move on to the 4 walnut legs, and we'll move on to the walnut finger pulls, which are really a wonderful accent piece. So let's go over to the machine and let me show you how I laid out all the plywood parts. Well, let's talk about setup and joinery on the different parts that form the carcass. What you see here is the bottom. A couple things to point out. These 2 grooves here are for the sliding doors. This back groove holds a 1/4 inch piece of plywood for the back of the cabinet, and that cabinet back will give it shear strength. This center groove holds a vertical divider, which allows us to put shelves in the unit. What's really interesting though is the joinery. We want a joint that's going to fit well and be strong and look great. CNC joinery can always be a little bit vexing, and that's because the router bit can't cut tightly into a 90-degree corner. It always leaves a fillet. So how do we work around that filleting? Well, a box joint is a great joint, but we have to do a couple different workarounds. So in this box joint, you can see a T-bone has been used. A T-bone then is a little overcut of the corner, and it just clears things out so that the fingers of the joint can come together tightly. It works great, but in my opinion, it just doesn't look very good for a furniture piece. For a mid-century modern credenza, I want it clean. I don't want to see anything. No little holes here. It needs to be strong. It needs to work well. Well, we can do that. What we're going to do here is form a blind box joint. Blind because it's going to include this little 1/10 of an inch coverlet of material. And that is going to eliminate the ends of our fingers and eliminate the visual problem that all these T-bones form. These pins have been laid out at approximately 1/10 of an inch. They're actually a little bit shy because to allow room for glue, for inaccuracies in the machine, I've cut the sidewalls back by about 3/1000ths on each side. The depth is 0.61 inches. It's 0.61 because Baltic birch, being metric, is an actual 0.71 inches thick. I want my coverlet to be 1/10 of an inch thick. You can go thinner if you like, but that gets a little tricky sometimes. So 1/10 out of 0.71, we get 0.61. This is the side of our cabinet. And as you can see, the joint looks pretty much the same. We've got a groove in the back for the plywood back. We've got some holes for shelf pins. I have holes here which screws will be placed through to hold the walnut legs on. The box joint is cut very much in the same fashion. It has the T-bones that we've talked about. It's 0.61 deep. I didn't take the 3/1000ths off of each side, so these are true 1-inch wide pins. On this end, our coverlet is flush with the end, whereas on our bottom, the coverlet extends out just a little bit. When the joint comes together, it's a little snug, but it's going to be clean on the inside, as you see on our sample. And the coverlet will cover the ends of those pins, and we'll have a nice clean corner, and that's what we want. All right, I've got all 4 legs cut out now, but I wanted to show you something about the legs before I took this last leg out of its blank. First off, remember when we talked about joinery, the router bit is not going to make a sharp 90-degree cut. It always leaves a fillet. Well, the plywood box that we're making has to sit on this ledge, and so it needs to nest tightly into the corner. So as you can see here, I've went ahead and put another T-bone to relieve that space, and this way our plywood carcass is going to fit tightly within the leg. Also, when we were cutting the plywood parts, we used a down cut bit with all that joinery. It made for a nice clean finish. But a down cut would be a bad choice for this. It's solid wood and it's very deep, so I switched to an upcut bit because it helps to draw the chips up out of the cut. Also, I made this vertical divider to finish up the 3/4 inch plywood parts for our project. It has some holes for shelf pins and 2 relief cuts to help it sit tightly down in the plows that we put in the top and the bottom. Last thing we're going to do is make a couple 1/4 inch parts, the 2 doors and the back, and I'm going to do those at the table saw, a little bit easier. Well, I'm going to go ahead and break out this final leg, clean it up a little bit, and we are going to be ready to glue up the carcass. Well, it's time to glue things up. So to glue up our carcass, I'm going to use liquid hide glue. This glue is a little bit slower setting than a yellow carpenter's glue, and it has sort of a little more slimy feel to it, so it actually helps things go together a little bit easier. But mostly, I'm trying to buy time here because I've got a lot of joints to put glue on and a number of parts to put together. I'm going to start with the bottom, a side, a back, my vertical divider, and finally the top. One thing that I would like to point out to you is that I used cauls on the corners of the joints. And those cauls do 2 things. One is they prevent the clamp face from marring our finished surface. Second, they help spread the force of the clamp out. Another thing they do is they also help provide firm, even pressure of that thin 1/10 of an inch coverlet over the ends of the pins. And with that extra pressure, we get a nice tight joint that'll look good. Well, with the top, bottom, sides, and divider glued up, it's time to move on to put some edging around the front edge of our carcass. So what I'd like to do is cover up this plywood edge, and I've cut some about 1/10 of an inch thick maple edging. You could also use pre-made rolls of veneer. That'll work fine too. I've got my ends pre-cut and ready to go. Now, when we glued up all these pieces earlier, I used hide glue because it's slow. I don't really need things to be slow this time around, so I'm just going to use a regular yellow glue. I'm going to put a bead on this front edge, smooth it out with a brush, and we'll be ready to go ahead and apply our first piece of edging. Now to keep the edging tight and in place until the glue dries, I'm going to use the simplest of clamping techniques, masking tape. What I'll do is just take a piece of it, place it over the edging, firmly pull down and tape it to the top and bottom of the side. I'm going to put a piece of tape about every 6 inches. So now I'm just going to repeat all the way around. Okay, that's got the edging in place. So now I just let everything dry and I'm going to come back, sand everything, scrape it, get it all ready for the next step, which is to finish the doors. To finish out the doors on our cabinets, we're going to make walnut finger pulls. And these are really going to look sharp because the legs are also walnut, so they're going to really be a nice detail. To make these finger pulls, it does require 2 individual steps. Now the first step is that the machine is going to come along and it's going to cut out this recess. And it's also going to drill 2 holes which will act as indicator holes. When the machine's done drilling out 2 recesses for the finger pulls, I'm going to remove this stock, flip it over, and then using the 1/4-inch holes that it's drilled in the board and into the spoil board, I'll use dowels to locate the exact position of the workpiece. We'll clamp it back down again, and in the next round of cutting, the machine is going to waste out some stock, creating this lip, and then finally it will cut the perimeter out, and will also leave a tab so that these pieces remain attached to the parent stock. When that's done, I can pop these out, sand them, and they'll be ready for the doors. Installing the legs is pretty simple. I'm using a 3/4-inch piece of plywood as a spacer. So I've spaced these bottom legs 3/4 of an inch off the table, pre-drilled and screwed them in place. These top legs are 3/4 of an inch behind the face of our cabinet. With the leg clamped in place, I've gone ahead and pre-drilled, and I just need to sink a few screws. And that completes the legs. So next up, we'll put in the doors. Well, here's our completed carcass. As you can see, I've added 2 shelves using shelf pins and the holes that we had drilled in the sides. So let's talk doors. I've got 2 doors here. Each one has a 2-inch hole, and I've put in the finger pulls that we just finished cutting on the router. And there we go, our mid-century modern credenza, all made on our CNC machine. And recently I was doing a lot of cutting on the CNC, making 1/4-inch plywood parts for a tab and slot tool tote. Well, the top surface looked great, but when I took the parts off the board, that's what I saw. The back is chipped, it just looks awful. So what could I do to make the situation better? Well, I think a lot of what was happening was that the plywood was actually bowed off the surface of the spoil board, and then with a down cut router bit that I was using, it was just blowing out the back terrible. To try and make things better in the future, I need to make sure that when I have a piece of plywood, if it's bowed, I make sure the bow is down so it holds itself flat. When using other materials like plastic, I can use double-sided tape to make sure that it's firmly down on my spoil board. Things like metal can be a little bit tricky. In this case, I've used liquid hide glue, which works just great for attaching thin metal that's easily damaged and easily torn off. When I'm done with my cutting operation, I just throw this in a bucket of water, the liquid hide glue will release, and I can take a sheet of metal, cut very intricate designs in it, and get it to lift off with no damage whatsoever and make it fit perfectly for inlay work. Another important factor in the equation of getting work that's not torn up is to use the correct bit. You know, I really like down-cut bits for a lot of operations, but I would have been so much better off here if I'd used a straight bit. A straight bit has a neutral geometry, so when the cutting edge hits the material, it's not going to lift it up, it's not going to push it down, and that's going to go a long way for cleaner cuts in thin materials that are prone to this sort of thing. So, two things to think about then. Holding your work very firmly down and always making sure you use the correct bit for thin materials. Well, I got an interesting question the other day from a viewer of Basecamp, and it was asking about what are the advantages and disadvantages of a drive that includes a timing belt versus one that does not. So first let's go over our example here. This is our Woodsmith shop-built machine, and this is the stepper motor and lead screw for the Z-axis. As you can see, there's a simple shaft coupling between the two. So it is simple, 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 and that is the advantage here. There's not much to go wrong. But here's the disadvantage. Take a look at this motor on our Y-axis. That sticks out pretty far, and you can bet I have hit myself on that any number of times. So it's a simple setup, but you have the disadvantage of the motors protruding out in various spots. So you can't keep the whole thing compact, and it's prone to damage of the machine and to yourself. Well, let's take a look at a step up from that. This is our Inventables X-Carve Pro, and it sort of marries the two situations together. We do have a lead screw, but we also have a timing belt here. Now, timing belts come in all sorts of different sizes, all sorts of different tooth configurations, but they all have one thing in common, and that is they have these Kevlar fibers in them that make them impossible to stretch, so they're super accurate. This belt gives us an advantage in designing the machine because no longer does the motor have to stick out here where it could get damaged or hit. Instead, the motor is more or less folded back into the interior space of the machine. And that means that we have a really attractive looking machine overall. It's more compact, the format size is smaller, less prone to damage, easier for the operator. So there's a real advantage to using a timing belt. Both setups work great, both have their advantages. For a home built machine, you want simplicity, low cost, and this does it. For a cleaner looking machine and a machine that will give you better service because there's less things to potentially get hit and damaged. Over the last several years, I've received a number of questions about how do you choose your first CNC machine. You know, it's kind of bewildering. You don't know all that much about CNC machines, what you're going to do yet, and there's a lot of choices out there. So I thought I'd talk a little bit about that. Well, your options are from home built to kit built to a plug and play. A lot of different choices. Each one has certain advantages and disadvantages. I think a good place to start is to think about how you're going to interface with that machine, and that really means software. So much of using a CNC router is dependent on doing designs in software, converting those designs to G-code, and operating the machine itself through a computer. So it's worth taking a look at that before you buy. Many companies use third-party software for all or part of the operation of their machine. Now, take this home-built Woodsmith machine here. We use a third-party program called Mach 3 to actually operate the machine and make it move. Vectric V-Carve is my choice for creating designs and putting them into G-code. There are other software available, of course. You're not locked into those. But this is what I've chosen. Each of these companies offers free demos. So when you look at a CNC machine, find out what software they're using and see if the demo is available and take a look. See how you like it. See if you're comfortable with it. Try a few sample programs out. And that's going to be true not only for home-built machines, but of course for commercially available machines as well. This is a Next Wave product, and they use Vectric V-Carve as well with their machines, and they have a proprietary system for the actual operation. In this case, the operation of this machine is primarily done through this pendant, which has an LCD touchscreen and is super easy and simple and friendly to use. Our big X-Carve Pro from Inventables, well, it has a proprietary system too for operating it, and it can use multiple programs for the design and for the running of the machine. So take a look and see what's required of you in terms of learning to operate the machine, and that's a good first step. The next thing I'd say is, think about what your plans are for the machine. Are you just interested as a hobbyist, wanting to learn, or do you have plans on becoming an Etsy superstar? If what you want to do is use the machine for production purposes, that's a little different. You need a machine that's very straightforward and versatile and easy to operate if you're going to be producing a lot of parts. You don't want to waste your time with various nuances and a lot of excess learning, so you want straightforward. You also want something that is mechanically very rugged and dependable. Now, rugged and dependable usually means it costs a little bit more, but if your plans are to use that machine heavily, it's well worth it. The final consideration I think that everybody thinks about is the format size. This is a 2x4 foot machine. Our Next Wave machine here is 2x2 feet. Now, of course, when I think of a CNC machine, what would I like? I immediately think 4x8 feet at least, big, heavy, lots of flashing lights, lots of bells and whistles. But the truth of the matter is, you would be surprised at how much you can accomplish, how much you can do on a smaller format machine like a 2x2. 2x4 is a great option if you got the space for it, but a 2x2 generally is going to hit a nice price point. You'll find a space for it in your garage or your shop. And using a procedure called tiling, in which you do a portion of a larger piece and feed it through the machine, you can do very large work. So this machine is 2x2. My limiting factor is 2 feet wide, but the length, well, it could be almost anything. So if you want to create a 2x10 foot sign, there's no reason you can't. You just have to do it in bite-sized pieces. So price, of course, comes into play here. I think one of the things I would say to wrap things up is that do not feel like you're making the ultimate decision that this is the last CNC machine you're ever going to own. You can always sell your machine off and upgrade or change as you become more familiar with what you want from your machine. So don't let making the choice intimidate you. Make the best choice you can, get a CNC machine and start having fun. You'll be glad you did. This episode is sponsored by Inventables. Design it, build it, sell it. Learn more at inventables.com.